Welcome to CoJo's Math. Today we're going to talk about polyhedrons. And let me just get this off the top. So now you're going to take notes. Let me move my book here. Woo! Okay, ready? Okay, so today we're going to talk about polyhedrons. Polyhedrons. And you need to know how to spell that. Well, polyhedrons are 3D shapes. Okay, so they're going to be shapes that looks to things like this. Okay, 3D shapes. And then they have two names. And there's parts of polyhedrons that you need to know and you need to be able to identify. And that are there's faces, edges, and a vertex or vertices. They're made up of vertices, not vertexes. The plural of a vertex is where the two edges meet, makes a vertex. But the vertices are all the points on the polyhedron. But a polyhedron, what makes it a polyhedron is it's made up of shapes. The faces are the shapes that make up the 3D figure. Okay? So polyhedrons are made up of shapes. That's very important. So the faces are what shapes do you have and how many faces do you have. So if you look at this, what do you have here? What shape is that? That's a square. But then you have another square, and you have another square. And you could potentially call it probably a rectangle, but I would call these squares. And then you have two more shapes. You have three shapes. This one is a triangle, and this one's a triangle. Okay? So this has a name, and how do you name a polyhedron? You just don't say, here's a polyhedron, because this is a polyhedron too. But it looks different. Now, it's got a base that is a triangle, just like this, but it's not called, doesn't look the same, so you can't say these are triangular polyhedrons. And that's what leads us into the two types of polyhedrons there are. There are prisms and pyramids. Pyramids come to a point. Prisms have the same shape on both ends of the base. So this would be called a triangular prism because there's a triangle on the top and there's a triangle on the bottom. You wouldn't call it a square or rectangular prism because it's not opposite. This is like a tent, so it wouldn't be opposite. The way you name a polyhedron is what shape is on the opposite ends that's the same shape. So this would be a triangular prism. You might stand it up like this, but it's called a triangular prism. And this one's called a triangular pyramid because it comes to a point. And the base doesn't have anything opposite. That's really important. So the faces are the shapes that make up the polyhedron. And then I would say, how many faces does this one have? 1, 2, 3, and the one on the bottom. So it has 4 faces. The edges are where 2 faces meet, and there's an edge formed. There's 2, each 2 faces meet. See that? So how many edges do we have? 1, 2, 3, 4, 5, 6. Because you have to count where they come when all the faces meet. Then that leads us to our vertex. How many vertices do we have? Vertices are where the 2 edges come to a point from the faces. So there's 1, because 3 come together on the pyramid. There's 1 vertex, 2, 3, 4 vertices. On this one, how many faces do we have? Well, we have 2 bases, and then we have 3 that make up the body of the polyhedron. So that's 5. All right, so we have 5, and how many edges do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. See that? Edge, edge. So we're talking about the edges here, the edges around it, and the edges on top. And then how many vertices do we have? 1, 2, 3, 4, 5, 6. Because we're looking for the points. All right. So this would be called a what kind of prism? We look at the top, and we have to assume there's one on the bottom, and that one's going to look like this. See that? So I'm kind of like a cereal box, a box of granola bars. So what do you call that prism? It's a prism because it has the same shape on each end. It's a rectangular prism. Good. And then the pyramid, I showed you, this is a triangular prism because there's a triangle on the base and a triangle opposite. And then we talk about this, that this is a triangular pyramid because it comes to a point. Okay. So based on the definition of polyhedrons, you should be able to tell me whether or not these represent polyhedrons and what name you have. So is this a polyhedron? You look for the three things. You look for faces, vertices, and edges. Well, this is a cylinder. And remember our cylinder? Let me get one. So our cylinder. Are there any edges? This isn't an edge. It's circular. So there's no edges. Now there's a couple of faces. There's a circle and a circle. And if we open this up, it would be a rectangle. Remember, we talked about that. But this has no edges, it has no vertices, and it has no faces except on the bottom. All right? So this would be a no. This is not a polyhedron. This one is a rectangular prism. It has faces, edges, and vertices. So that is a polyhedron. What about this one? That's like a cone. That's a circular. Now, it's got edges here, or does it? Think of an ice cream cone. It's like a cylinder, it just comes to the close at the end. So this has a point, but it's coming together from a circular path. So this is not a polyhedron. And it has to have all conditions. And this is a triangular prism because it has a triangle on the top and a triangle on the bottom. It has faces, edges, and vertices. So you learned today just the basics of polyhedrons, how to identify them and how to name them. Remember, to name them, you go to the base of the polyhedron. So here we go. This one isn't called a rectangular polyhedron because it's attached to other things. The body of it is attached to other things. You look at the base where there's only one end, one face, directly opposite the other face, and nothing else. So 1, 2, 3, 4, 5, 6. That's your challenge. Find out what a six, it's not an octagon. An octagon would be an octagonal prism, but this isn't an octagon. This has 6 edges. So that's your job is to find out what is a 6-edged figure called, and then you'll have the name of the polyhedron. So good luck, and I'll see you in class tomorrow. If you have any questions, write down any questions you might have. I'll see you tomorrow. Or I'll see you in class next time, whenever that might be.